Greetings everyone, I'm Anush Trivedi from the Chemical Department.
Hello everyone, I am Shlok Agarwal from the Chemical Department.
So we are going to elaborate on the topic, the heat exchangers.
So let us start with a brief idea. So what is heat exchangers? Basically, heat exchangers are the devices designed to efficient transfer heat from one medium to another. They are commonly used in various industrial processes as well as in everyday applications like air conditioning, like refrigerator, like heating system. The basic principle involves two fluids, typically a hot fluid and a cold fluid, flowing in separate channels or passages within the exchangers. These fluid exchanges heat through a solid barrier without mixing each other, resulting in efficient transfer of heat from the hot region to the cold region.
The heat exchangers can be classified on the basis of the flow configuration.
So on that basis, there are four basic flow configurations, namely the counter flow, the co-current flow, the cross flow, and the fourth one is the hybrid flow, which includes all the above processes.
So as you can see, this figure illustrates an idealized counter flow exchanger in which the two fluids flow parallel to each other but in opposite directions. So this type of flow arrangement allows the largest change in temperature of both fluids and is therefore the most efficient. Moving to the next, the concurrent flow heat exchangers. The streams flow parallel to each other and in the same direction as shown in the figure. This is less efficient than the countercurrent flow but does provide more uniform wall temperatures. So coming to the next one, cross flow heat exchangers. These are the intermediate in the efficiency between countercurrent flow and parallel flow exchangers. In these units, the streams flow at right angles to each other as shown in the figure. So in industrial heat exchangers, the hybrids of the above flow types are often found. Examples of these are the combined cross flow counter flow heat exchangers and also the multi-pass flow heat exchangers.
Okay, so now let us see the types of heat exchangers and its uses. So basically, the first type is the direct contact heat exchanger, the fine tube heat exchanger, the plate heat exchanger, micro channel heat exchanger, the double pipe heat exchanger, the phase change heat exchanger, and the last not the least, waste heat recovery unit. So now we are going to cover the phase change heat exchangers in some more depth. So Anuj, I have a question for you. Focusing on phase change heat exchangers, could you please elaborate its uses and the concept behind it?
Sure. So a phase change heat exchanger is basically a device that utilizes the clever property of materials to absorb or release heat during a phase change, like turning from liquid to gas without a big temperature jump. So this lets them transfer a lot of heat for this size. And Shlo, could you elaborate and give a more practical example of it?
Okay, so let us assume a pot of water on a stove. As you heat it, the temperature rises until it reaches its boiling point. Then after, even though you keep on heating it, the temperature stays the same, but the water turns into steam. The extra heat energy that is being absorbed to cause the phase change, not the raise to temperature. A phase change heat exchanger uses a similar principle. It has a working fluid inside that absorbs heat, causing it to change phase, typically from a liquid to a vapor. This vapor then travels within the exchanger to a cooler area, where it condenses back into liquid, releasing the heat absorbed, and in this way it forms an efficient cycle that goes on, and our phase change heat exchangers works practically.
Okay.
So I think my example has made you clear about the principle of the phase change heat exchanger.
Yeah.
So let now explain the working of the phase change heat exchanger. So could you please try to explain it?
Yeah, so in a heat exchanger, there are basically three main players.
Okay.
One is the working fluid.
Okay.
So this is the key player, a substance that changes phase, usually from liquid to vapor during operation. So common choices for working fluid include water, refrigerants, or even specific metals.
Okay, so basically same as we use in refrigerators.
Yeah.
Okay.
The second one is hot fluid. This is the fluid that carries the heat you want to remove. It could be engine coolant, hot air in a building, or any steam that needs cooling. And the third one is the cold fluid. This is the fluid that absorbs the transferred heat from the hot fluid. It could be cooling water, outside air, or any stream needing to be heated.
That was some important information which was mandatory to be known for understanding the process in a good way.
Like, to get a more clear understanding, could you elaborate the process of the heat exchanger?
Okay, so I would like to elaborate in point wise. So the first point covers the basic what we have been discussing from past few minutes, and that is heat transfer. In this, the hot fluid flows from one side of the exchanger, transferring its heat to the wall that separates it from the working fluid and the cooler side. Okay, so now in next step, evaporation occurs. As the wall heats up, they transfer heat to the working fluid. This heat causes the working fluid to absorb energy and undergo basic phase change, typically from liquid to vapor. During this change, the working liquid absorbs a significant amount of heat, which is known as latent heat, without a large increase in temperature. Okay, this is the magic of exchangers. Now, In the next process, the vapor movement occurs. The vapors that are being formed, being less dense than the liquid, rises within the exchangers and then moves towards the cooler side.
Cooler side, yeah.
Then, as a hot thing moves towards the cooler side, we know condensation occurs. Okay, so on the cooler side of the exchanger, these hot vapors encounters cooler walls, due to which it loses its heat and condenses into liquid
form.
During the condensation, the working fluid releases the latent heat which it has previously absorbed. Okay, so this is basically the heat exchange to the cold fluid. The released heat from the condensing working fluid is transferred through the walls to the cold fluid on the other side. This heats up the cold fluid, and as the cold fluid heats up, steams are being formed. They are back moved to the working fluid, where on the move.
So it goes on repeating and repeating.
Where it goes on repeating from the hot side to the working fluid, from the working fluid to the cold fluid.
Basically from the cycle.
Basically from the efficient cycle, and because the energy transferred, energy absorbed is basically within the exchangers, this cycle is efficient as in case of heat losses. Okay, that was some good information, and the principle was explained, I think, clearly. So, but nothing is done without a purpose. So the basic purpose, we are discussing the topic and the theory for past few minutes, is what?
Is we have to apply it somewhere or use it for
the practical applications in day-to-day life. Okay. So I think let us now cover some of the practical applications and target our audience for the same.
So the first applications come as the electronic cooling, like managing the heat in devices. The PCHCs, which are the phase change heat exchangers, are increasingly used in computers, servers, and other electronic devices to manage heat generated by processor and other components.
Okay, computer servers, like heavy computers and servers.
To keep them cool.
Okay, so the next application is HVAC systems. So basically the PHCs, which he stated, phase change heat exchangers, can be integrated into air conditioning systems, which we see in our day-to-day life, like it is very common, to improve efficiency and reduce energy consumptions. Because green energy and energy efficiency, energy conservations are
good for the environment.
And are trending topics of this market.
Exactly.
Okay, they can capture waste heat from the exhaust air steams and pre-cool incoming air.
Like it also has many. So till now we have talked about what are heat exchangers, their working, how do they work, and where they can be used. And we have also elaborately discussed the PCHC specifically, which are the phase change heat exchangers. So let's now talk about the advantages. So
okay, so the very first advantage is that it is efficient in energy control. Like during the phase change, the working fluid absorbs or releases the significant amount of heat without a large temperature increase, and this translates to a much higher heat transfer capacity as compared to the traditional exchange heat density. So due to the efficient utilization of latent heat, as discussed in the first advantage, the phase change exchangers can achieve a high heat of transfer in smaller volume as compared to the traditional options, which in turn makes it ideal for the applications with limited space constraints, and especially in electronic cooling or aerospace where weight is critical.
Yeah, exactly. And also in the isothermal operations, since the phase change process happens at a constant temperature, these exchangers can maintain a very stable temperature output for the cooled fluid. And so this process is crucial for applications requiring the precise temperature control, like sensitive electronic components or specific chemical reactions.
Actually.
So our next topic of discussion is electric vehicles. So an EV is defined as a vehicle that can be powered by an electric motor that draws electricity from a battery and is capable of being charged from an external source. An EV includes a vehicle that can be completely run by battery, and also the vehicle which can be partly powered by EV and partly by a combustion engine, which is also known as a hybrid model of a vehicle.
EV have been a prominent topic in our day-to-day life again because of its market and its consumer values, like the rise of mobility or micro-mobility. Exploring the growing popularity of e-bikes, e-cars, e-scooters and other electronic vehicles for short trips and urban transportation is energy efficient and less cost causing to the employers.
It's more cost effective towards middleman's.
Okay, so the next reason is consumer incentives and government policies. Okay, discussing the role of government, subsidies, tax and regulations in driving electric vehicles is less as compared to the combustion vehicles, which in case also helps the consumers only. And also the future of ownership models.
And this also shows a positive outlook of government towards electric vehicles, as they're providing a lot of subsidies and facilities to the companies which want to set up their workstation of factories in the nation for the development of electric vehicles.
And all this was our presentation
on the topic heat exchangers.
And specifically covering the phase change heat exchangers
and the electric vehicles. So we hope that the information we provided was relevant.
and helpful in informative and helpful as it was an informative project for us also, and has helped us understand and explore our industry, our chemical industry more prominently. Thank you.
Thank you.